we present QRSC towards nonlinear motion-aware and occlusion-robust rolling shutter correction. The RS cameras captures the image pixels row by row. The time slot between scan lines causes motion artifacts called the RS effect, e.g., wobble and skew. In addition to the detrimental visual artifacts, the RS effect damages numerous 3D vision algorithms based on GS assumptions, such as structure from motion and SLAM. Therefore, RS correction is significant in photography and has attracted considerable research attention. This paper addresses the problem of RSC in complex nonlinear and dynamic scenes with extreme occlusion. Existing methods suffer from two main drawbacks. Firstly, they face challenges in estimating the accurate correction field due to the uniform velocity assumption, leading to significant image correction errors. Secondly, the occlusion in dynamic scenes prevents them from better image quality because of the difficulties in aligning and aggregating multiple frames. The proposed method receives a video stream and precisely corrects the RS images with a geometry-based multi-QRS motion solver, and a 3D video encoder-decoder architecture extracts the features of corrected frames. After that, the hierarchical RSADACOF modules align and warp the features to produce a final synthetic, high-quality GS frame. To address the correction field estimation problem under complex nonlinear motion, we use the second-order Taylor expansion around T0 to formulate the motion of each pixels. According to the scanning mechanism, the relative time can be expressed as, considering the trajectories from MRS0 to MRS-1 and MRS1, we obtain the matrix M, which measures the quadratic motion of pixels MRS at T. Given the optical flow vectors and the relative times, we can solve the linear equations and obtain the quadratic motion matrix M efficiently. Thus, we faithfully compute the correction vector UCORR0 to tau from Mrs0 to any timestamp tau. Thus, by given 3 consecutive RS images, the RS distribution point can be corrected to corresponding GS measurement at any timestamp by prime QRS motion solver. Although the solver accurately corrects RS pixels, the object edge occlusion and image border occlusion cannot be restored by it. We design a self-aligning algorithm by extending the QRS motion solver to a video sequence. RS frames IRS-1, IRS-0 and IRS-1 are warped to time tau to obtain 3 RSC frames. We achieve a seamless and complete composite overlaid image. However, slight horizontal or vertical offsets exist between the RSC pixel and GS pixel in extreme motion, which is not fully modeled by the QRS motion solver. We adopt deformable kernels to represent offsets alpha and beta and the weights W for frame IRSC. Considering the RS scanline mechanism, different pixels hold individual relative positions, and the quadratic model degrades gradually with increasing temporal distance. Thus, we propose to dilute the degradation using the completely independent differential temporal distances. The results reported in table show that our method outperforms the others by large margins, demonstrating the effectiveness of our model on dynamic scenes with occlusion and curvilinear movements. We performed cross-tests on 3 datasets, benefiting from the QRS motion solver. The proposed method demonstrates strong generalization performance. There we show more visual comparations with existing RSC algorithms in complex nonlinear motion and dynamic occlusion scenes. Besides, we evaluate the ORB-SLAM2 augmented by QRS motion solver on TUM dataset.